we'll bring it back. We'll bring it back in time, I promise. Because it's going to serve us well. The first thing is, you have to decide what variable you're testing. So, I give you two choices at the top. Circle one, little p or little mu. Now, this must be gotten from the context of the problem. So read back the original data sheet again and decide what we're testing if you don't already know the answer. You might already know the answer, just because we've already mentioned it a couple times.
For the flu vaccine?
For the flu vaccine, yes, we haven't even tested this yet. We haven't
Testing the effectiveness.
But what variable are we going to be testing in that? How are we going to measure the effectiveness? Based on the way, and this goes back to Danielle's point from about 10 minutes ago. What variable appears in this data? Little p, a percentage, yes. If we were trying to see the effect on the body temperature of a flu victim, that would be mu, because we'd be measuring the temperature. But what we're measuring is the percentage of those that get sick on the flu vaccine. That's what we're looking at, right? So we're looking at little p. So go ahead and circle little p. That's step one. Step one is knowing what variable you're analyzing. And you have to know that because as we go through this course, the remaining 5 weeks we have together, we're going to build a flow chart together. Where you start at the top and you start basically with, what am I testing? Sheesh. How many of them am I testing? Sheesh. What do I do? Sheesh. So you have to kind of get in the tree correctly so you know you're in the right branch. So there's your right branch. We're testing little p. Good. Now we have to define little p. I'm big about this. This is something my professors never made me do in Stat 371 and 72. And it kind of pissed me off. Still love you, Dr. Howard. You were wonderful. However, not knowing what the variable, we now know it's little p, yes? What in particular are we interested in studying about little p?
I have a question.
Oh, please, ask me that question.
So if 12% of people get flu,
Yes.
and there were 1,000 vaccinated,
Yes.
and 101 got the flu,
Yes.
so that's 10.1%.
Yes.
So that's 1.9% difference.
Hold that thought. You're about 5 steps ahead of me.
Oh,
Because I want to know, what is that one, well, let's come back to that, if you don't mind, Frank.
sorry, no, I was just...
Because the
trying to get-
1.9% difference needs to be metric by Natasha's scale of what
Yeah.
1 means. Let's come back to that if it's
To
okay.
show if it's effective.
Oh, yes, exactly.
Right.
Because it might or it might not be. It depends on what 1 is. Let's come back to that if it's okay. I want to, for sure. So in words, not in numbers, we're getting to the numbers soon, but in words, what is little p? What do you think we're interested in? What would little p be in words? The percentage, let's write it down, it's the percentage or the proportion, your choice of word, probability. It's a percentage, keep going. Say it, go ahead, be brave. It's the percentage of those, keep going. The percentage of those that got vaccinated that got the flu. That's what we're going to be measuring. That's what, look at our sample. Our sample collected 1,000 people, gave them the vaccine, and 101 of them got sick, yes? So what we're tracking is, we're tracking the percentage of those that got sick using the vaccine. Let's make sure that makes sense. Let that sink in. Percentage of those who got the vaccine and then got the flu.
Worst of both worlds.
Say that again.
That's the worst of both worlds.
Get the well. But the thing is that Blake, it's always going to happen. The question is, does it happen at people are always going to get sick from the flu, yes? They're always going to get sick from the flu. It never goes to 0. If it goes to 0, we have the polio vaccine, essentially, right? But people still get sick with vaccines, but they get sick at a lower rate. That's what we're testing. So I love what you're saying, Blake. It's the worst of both worlds. You get the vaccine, then you get sick and you get pissed. It's like me with my damn allergy shots. I go and I spend 6 months getting allergy shots, and after 6 months I get my second systemic, my throat closes, my eyes swell shut, and I can't breathe. I'm like, well, that was great. I'm really glad I spent 6 months getting allergy shots to stop getting allergy shots with no effect. So I'm with you on that. But the thing is, I'm an outlier. I'm an outlier. And we're going to see if those 10.1% are as well, you see? We're going to see if those 10.1% are as well. That's what we're getting to. Please.
Would P ever be the percent of those who did not get the flu
If
our
yes.
control, if we matched it to our control
Yes.
group? Is that what
Oh,
differentiates?
yes! That's a fantastic question. When you're defining, that's why I like this step 2. Make sure we talk about how we defined it. The question up here could be those who didn't get the flu. We could actually make that be the results here. We just have to say, instead of 12% of people get the flu, 88 don't.
Okay.
And in our sample of size 1,000, 101 got the flu, which means 899 didn't? I think that's right. Yeah. So yeah, we could totally do the, matter of fact, if you want, after the break, we'll run it the second way, show you the exact same results. It's binomial, correct?
Yeah.
So as long as you define the two groups congruently, they're going to be symmetrically opposed from each other.
Yeah.
Right? 12% is binomially symmetric to 88%.
Yep.
There's one way of counting my chicken flock. How many chickens did I get? I can also count how many roosters I got or didn't get. Same number at the end of the day, because it's binomial. Very good. I just chose to define it this way because of the way the data came in.
Yes.
They talked about the ones who were getting sick, not the ones who weren't getting sick. I know it's kind of strange to do that because you're talking about a vaccine. You might want to focus on those that are healthy.
Yeah.
But if you can prove that people are getting sick at a lower rate, that's just as good now, isn't it?
Yeah.
Right? They're going to get sick, but they're sick at a lower rate. Good. Thank you. Very, very good. Excellent. So that's the definition of the variable we're going to be testing. Fair enough? Okay. Great. Now I'm going to start again because that was a... And please keep them going.